Imagine an artificial intelligence. And I don't mean the kind that's, writing your emails for you.
Right, not the chatbot stuff.
Exactly, not the kind generating those surreal pictures of cats on Mars. Imagine an artificial intelligence holding a live, volatile explosive.
Which is a terrifying thought, honestly.
It really is. But right now, billions of dollars are just being poured into AI that lives purely on our screens, right? It's constrained by pixels and text boxes.
Yeah, completely digital.
But today's source material argues that if an artificial intelligence doesn't understand gravity or, geometry and the actual mortal danger of a factory floor.
Then it's already functionally obsolete.
Exactly, it's
Right.
obsolete. So, welcome to today's Deep Dives. We are stripping down this highly concentrated, incredibly specific piece of writing today.
It's a really fascinating document.
It is. It's an excerpt from a text titled The Architecture of Embodied Intelligence. And the funny thing is, it's actually just a draft of a LinkedIn post.
Right, which sounds casual, but it's really not.
No, not at all. The text itself includes this strategic preamble, explicitly labeling what this draft is meant to accomplish. It literally calls it an authority play.
Yeah, and that phrase, authority play, it immediately signals that we are not just reading some casual observation here.
Right.
We are analyzing a calculated, almost architectural blueprint for influence. Because, in the current technological ecosystem, authority is usually claimed through sheer volume.
Oh, absolutely. Everyone is shouting.
Exactly. Companies are just racing to publish benchmark scores, parameter counts, press releases about, theoretical capabilities.
Just flooding the zone with noise.
They really are. But this author outlines a completely different mechanism for capturing the high ground. They lean on a philosophy that they define as quiet impact.
Quiet impact.
Yeah. Planting a flag at the intersection of AI and hardware is this deliberate, very calculated rejection of the current software hype cycle.
Okay, let's unpack this concept of quiet impact because, honestly, it feels inherently contradictory to the nature of social media platforms.
Oh, for sure.
Like where this draft is intended to live. If you look at the current AI landscape, it feels like we are all sitting in the dark at this incredibly flashy magic show.
That's a great way to put it.
Right. We're absolutely mesmerized by the magician on stage pulling a rabbit out of a hat, which is, the chatbot writing code or sawing someone in half.
The image generator.
Exactly. The audience is just throwing trillions of dollars at the stage. But by choosing this quiet impact philosophy, this author is essentially standing down in the basement of the theater.
Pointing at the foundation.
Pointing right at the foundation and saying, hey, while you're all distracted by the flashing lights up there, someone actually has to pour the concrete.
And that foundational focus completely redefines what constitutes true technological advancement.
Because software is kind of fleeting, isn't it?
Yeah, software abstraction is totally ephemeral. I mean, an algorithmic breakthrough in image generation today, it'll just be superseded by a slightly better one next week.
Right. It's always iterating.
Because it operates in this frictionless vacuum where the cost of failure is basically negligible.
You just hit undo.
Exactly.
Huh?
Hardware, conversely, is bound by the unforgiving laws of thermodynamics and friction and gravity.
The real world.
The real world. So by anchoring their authority in physical machinery, the author implies that, the adults have finally entered the room.
Wow, yeah.
They are suggesting that manipulating data in the cloud is actually the easy part. The real revolution, the one that will actually reshape human infrastructure.
The concrete.
Right, the concrete. That only happens when that data can successfully manipulate physical mass without destroying it.
It is such a massive power move. It forces anyone reading this, we're talking about engineers, investors, tech leaders, to suddenly feel this cold sweat.
Yeah, a total paradigm shift.
It triggers this realization that, wait, they might be missing out on the actual revolution because they've been too busy, fine-tuning prompts on a screen. The author is taking the trillion-dollar valuation of the software-only AI space and aggressively waving it away as a parlor trick.
Which takes a lot of confidence.
It really does. And the background they present to justify this massive pivot in perspective is entirely rooted in extremes. They state their work lives entirely at the intersection of mechanical engineering and artificial intelligence.
Right.
And then they drop this incredible sentence, quote, I've watched factory workers handle live explosives, and I've trained LLMs on empathetic communication.
We really need to freeze on that juxtaposition.
It's wild.
It is. Watching a human handle live explosives represents the absolute pinnacle of high-stakes physical reality.
Yeah, no kidding.
Mechanical engineering in that specific environment operates with literally zero margin for error.
Zero.
If a human hand or, a mechanical actuator applies a fraction of a newton too much pressure, or if the shear forces are miscalculated by a single millimeter,
It's over.
the result is an instantaneous kinetic event. It is a domain governed by rigid binary outcomes, survival or destruction.
And then, on the completely opposite end of the spectrum, you have the training of large language models on empathy.
Right, the softest skill.
Empathy is the ultimate abstraction. It's fluid, it's highly subjective, and it's deeply human.
Yeah.
It requires an AI to read the emotional subtext of a text prompt, parse the cultural nuances of the words, and map out a response that feels comforting.
Which is incredibly complex in its own way.
Definitely. So you have the ultimate hard physical reality of dynamite and the ultimate soft digital abstraction of human emotion. And the text claims that the bridge connecting these two wildly different universes is something they call contextual translation.
And that mechanism, that contextual translation, is really the linchpin of this entire philosophy.
Okay, break that down for us.
Well, in the realm of a traditional LLM, contextual translation means the model is mapping words into a high-dimensional vector space.
Right.
It uses attention mechanisms to weigh the relationships between tokens. So it understands that the word heavy means something entirely different when applied to a physical box versus, say, a human heart.
Yeah.
Okay.
It translates raw text into semantic intent. The author is proposing that this exact same neurological architecture, this ability to weigh context and divine intent,
It has to be applied to the physical world.
exactly, it must be applied to the physical constraints of mechanical engineering.
I want to push back on this bridge a little bit, though, because the stakes are just so wildly asymmetrical.
They are.
Like, if I am interacting with an empathetic chatbot, and the contextual translation fails, say, the AI misunderstands my frustration and gives me this cheerful, toxic positivity response.
It's
So-
annoying.
Yeah, I roll my eyes, I close the laptop. The failure state is mild annoyance.
Sure.
But if we are translating that same cognitive architecture into a machine holding a volatile chemical compound, the failure state is a crater where a manufacturing plant used to be.
That's the reality.
So how can a system built on statistical probabilities and, token prediction ever be trusted in an environment where even a 99.9% success rate is completely unacceptable? That is the exact tension the text forces us to confront. The implication is not that we simply, upload a language model into a robotic shell.
Okay.
The concept of contextual translation in a physical space requires a fundamental architectural shift. The machine must dynamically read the physical context of the room with the exact same nuanced comprehension that an LLM reads a paragraph of text.
So it's reading the room, literally.
Literally. It means tokenizing physical space. The sensory inputs, like the temperature of the explosive, the microscopic degradation of the casing, the ambient vibration of the factory floor.
Wow, all of that.
Yeah, all of that must be translated into the same latent space as the natural language command it receives.
That immediately brings to mind the human nervous system.
Oh, perfect analogy.
Because when you or I reach out to pick up a fragile glass of water, we don't consciously calculate the exact torque required by our biceps or the exact friction coefficient our fingertips need to apply, right?
No, we just do it.
Our brain generates a high-level intent, and our nervous system performs a real-time contextual translation. It turns that abstract intent into a highly complex, totally unconscious series of physical adaptations.
Exactly.
If the glass slips even slightly, our grip tightens dynamically without us having to write a new line of conscious code.
The text seems to be arguing that industrial machinery needs an equivalent nervous system.
And a synthetic nervous system is the perfect segue into what the text introduces next, which is embodied AI and vision language action models, or VLA models.
VLA models.
Right. The source explicitly declares the death of the automated arm with rigid code.
RIP.
Yeah, seriously. Because for decades, industrial robotics relied entirely on rigid kinematics. A programmer would write a script forcing a robotic actuator to move to a very specific set of XYZ coordinates.
Blindly.
Completely blindly. The machine possessed zero awareness of its environment. If an obstacle fell into its path, or if the target object was shifted by just 2 centimeters,
It would just smash right into it. It would blindly execute its code, crushing the object, or completely destroying itself in the process.
so it's pure execution without even a shadow of comprehension.
None.
The text states that the new goal is to give these machines a cognitive architecture, and it breaks it down into three very specific pillars.
Let's hear them.
Pillar 1, quote, understand a natural language command. So we're moving away from punching in coordinates. The human operator is now speaking to the machine the way they would speak to, like, an apprentice.
Right.
The command might be, carefully move the volatile material from the transit case to the assembly table. And the word carefully carries immense weight here.
It does. And interpreting the word carefully requires the machine to access that empathetic contextual translation we discussed earlier, but map it to physical action.
So it has to know what careful looks like physically.
Exactly.
Yeah.
It must understand that carefully means minimizing acceleration, avoiding sudden jerky movements, maintaining a specific orientation to prevent chemical agitation. All of that, which naturally flows into the second pillar. Quote, interpret the physical environment.
Okay, so vision.
Right. The machine must utilize sophisticated vision models to parse the really messy, completely unstructured reality of a factory floor.
It's never as clean as a lab.
Never. It has to identify the specific volatile material among a clutter of other objects, calculate the spatial geometry of the room, and recognize dynamic obstacles in real time.
Which means it has to overcome issues like occlusion, right, where an object is partially hidden.
Exactly, or sudden changes in lighting.
Right, things that would completely baffle a rigid, old-school optical sensor. And once it understands the verbal command and interprets the physical space, it hits the third pillar, quote, execute the task autonomously.
The action part of vision language action.
Exactly. The model has to dynamically generate the required physical movements, the motor torques and doing the angles on the fly. No human is writing the scripts for this specific movement.
It's improvising, essentially.
Yeah, the AI is generating physical action the exact same way ChatGPT generates a sentence, token by physical token.
And that leap, from generating text tokens to generating physical torque vectors, it represents just a monumental shift in computational complexity.
It has to be massive.
It is. A language model operates in a closed digital system where the rules of grammar are relatively static.
Sure.
But a VLA model operates in an open physical system where friction coefficients change based on ambient humidity, where motors experience microwear and tear.
Gravity exists.
Where gravity is a constant, unforgiving variable, the machine is actively thinking about its own mass and the mass of the object it is manipulating at all times.
And here's where the text gets incredibly aggressive. The author establishes this requirement for cognitive architecture and then delivers what I consider the hardware mandate.
Oh, this part is intense.
They write, quote, we don't need AI that just talks. We need AI that understands physics, geometry, and human safety.
It's a direct shot.
It is a direct assault on the economic hierarchy of the tech world right now. We have companies valued at trillions of dollars purely because they build AI that just talks.
Right.
The market insists that conversational AI is the absolute pinnacle of value. Yet this text looks at those trillion-dollar algorithms and basically dismisses them as totally inadequate if they lack an intrinsic understanding of geometry.
Because the author is highlighting the fundamental bottleneck of software abstraction.
What do you mean by that?
Well, think about it. You can ask a state-of-the-art language model to design a suspension bridge, right?
Sure.
And it will generate a highly articulate, grammatically flawless document outlining the materials in construction phases. It sounds brilliant.
It sounds like an engineer wrote it.
Exactly. But that model possesses zero intrinsic understanding of tensile strength or wind shear or load-bearing geometry.
It doesn't actually know what a bridge feels like.
Right. Its output is essentially a high-resolution hallucination of a bridge. The text argues that words are cheap, but physics is expensive.
Physics is expensive. Wow. And if the AI doesn't understand the physics of the bridge, it cannot guarantee human safety. Which brings us to the most brutal, uncompromising line in the entire draft.
The 2015 line.
Yes. Quote, a great prompt is entirely useless without a great physical product behind it. If you are building hardware without integrating generative cognition, you are building for 2015.
That's a mic drop.
I really want to dwell on that phrase, entirely useless. They didn't say it's less valuable. They didn't say it's only partially effective. They drew a hard line in the sand regarding the absolute necessity of a physical product.
And that absolute finality is the core of the authority play we talked about earlier.
Right.
The author is forcing a bifurcation in the industry. They are stating, flat out, that software without physical grounding is merely entertainment.
Entertainment. Just toys.
Exactly. And hardware without cognitive architecture is a relic.
A relic from 2015.
Yeah, and the choice of the year 2015 is particularly telling. It serves as this really specific historical anchor point for technological obsolescence.
You know, my theory on why they chose 2015 is that it represents the absolute peak of the blind automation era.
Oh, interesting.
Like, just before the deep learning revolution truly began to bleed into physical robotics. Because in 2015, if you walked into an advanced manufacturing facility, you would see incredibly fast, highly precise machines.
Beautiful to watch, honestly.
Yeah, mesmerizing. But they were essentially brilliant zombies.
Yes.
They were the culmination of Industry 4.0, hyper-efficient, heavily networked, but entirely reliant on human programmers to dictate every single millimeter of their movement.
Your assessment of the 2015 timeline aligns perfectly with the evolution of neural networks.
Really?
Yeah, because pre-2015, the computational power and the architectural frameworks required to process high-resolution visual data and map it to complex robotic kinematics in real time, it simply did not exist at scale.
You just didn't have the juice.
We didn't. So, a multi-million-dollar robotic arm built today, if it still relies on rigid waypoints and human-scripted code, is functionally a decade out of date the very moment it boots up.
That's wild.
It is a spectacular puppet just waiting for its strings to be pulled, completely incapable of the contextual translation required to actually navigate an unstructured environment.
So we've tracked this argument from its strategic origins on LinkedIn through the visceral contrast of live explosives and empathy into the mechanical reality of vision language action models, and finally to this uncompromising mandate that hardware and generative cognition must be fused.
Right, the full journey.
But that brings us to the ultimate philosophical climax of the source material. After all the discussion about geometry, physics, and cognitive architecture, the text steps back to answer the fundamental question: why are we doing this? What is the actual goal here?
And the text provides a closing thesis that fundamentally rewires the current socioeconomic anxiety surrounding artificial intelligence.
Okay, let's hear it.
The author concludes, quote, "Real technology doesn't just replace human effort, it restores human safety. Let's build things that matter."
Restores human safety. That is, I mean, if you listen to the loud AI discourse, the noise that this author is trying to cut through with their quiet impact.
The mainstream panic, basically.
Right. The dominant pervasive fear right now is the replacement of human effort. We are terrified of the economic implications of AI writing our code, designing our graphics, taking over our administrative tasks.
The anxiety of labor replacement is everywhere.
Exactly. The entire conversation is built around that panic.
Yeah.
But this text sidesteps that entire issue. It argues that replacing effort is just a trivial goal.
It's aiming higher.
Much higher. The true moral imperative of advanced technology is the replacement of human danger.
Returning to the image of the factory worker handling live explosives, that closing thesis carries such profound weight.
It really hits home.
Because the objective of developing embodied AI and VLA models is not to find a more cost-effective way to assemble a bomb so you can, lay off the human workforce.
Right, it's not about payroll.
No. The objective is to look at a human being who is sweating over a highly volatile chemical compound, knowing that a single microtremor in their hand could vaporize them.
Which is horrifying.
Right, and declaring that a human should never be subjected to that level of moral risk in the first place.
It is a radical reframing of industrial progress. If you are a mechanical engineer listening to this deep dive, you know exactly the toll that high-risk environments take on the human body and mind.
Oh, definitely.
It's about taking the human out of the blast radius. It requires building a machine with enough cognitive architecture to understand the lethal physics of the explosive, paired with the contextual translation to handle it carefully.
So the human can step back.
Exactly. So the human can step back into a role of oversight rather than being in physical peril.
And this philosophy is explicitly tied to the hashtags that conclude the draft, particularly the reference to Industry 5.0.
Industry 5.0?
Yeah. If Industry 4.0 was characterized by the relentless pursuit of efficiency through blind automation, often treating human workers as, the least reliable gears in the machine.
Right, the weakest link.
Industry 5.0 represents a necessary correction. It advocates for bringing the human back into the center of the industrial ecosystem, utilizing cognitive machines not to displace humans, but to collaborate with them, prioritizing sustainability, resilience, and above all, physical well-being.
So when the tech says, let's build things that matter, it is really throwing down a gauntlet.
It's a challenge to the whole industry.
It is a direct, unapologetic critique of the purely digital screen-based AI we discussed at the very beginning.
Hmm.
Like generating a synthetically perfect video of a cityscape might be a technical marvel.
It's cool, sure.
But does it actually matter in the grand scheme of human survival and flourishing? The author strongly suggests it doesn't.
Not compared to saving lives.
Right. But engineering a robotic system that can autonomously navigate a collapsed building to clear hazardous debris because it possesses true physical cognition, that matters.
That is the restoration of human safety.
The document is just a masterclass in synthesis. In just a few brief paragraphs, it establishes a strategic authority, diagnoses the fatal flaw in current AI development, proposes a complex architectural solution in VLA models, and anchors the entire technical discussion in this profound moral imperative.
It demands that we elevate our criteria for what qualifies as revolutionary.
It fundamentally changes how you look at the physical world. And as we wrap up this deep dive today, I want to issue a challenge to you, the listener.
Look around you.
Literally, look at the smart devices sitting on your desk right now. Look at the automated systems in your workplace or your car. Ask yourself, are these machines built for 2015?
That's the question.
If they fell off the table, would they try to catch themselves? Do they possess true generative cognition, or are they just executing blind, rigid code? Are they just talking, or do they actually understand the lethal reality of the physical world?
Evaluating our infrastructure through that specific lens reveals just how fragile our current technological ecosystem truly is.
Which leads me to one final, deeply provocative thought for you to explore on your own, building directly on the tension we've unpacked today.
This is where it gets really complicated.
It does. We have established the necessity of building machines with a cognitive architecture. We are demanding that they perform empathetic contextual translation, that they understand geometry and physics, and that their ultimate overriding mandate is to prioritize human safety in incredibly dangerous environments, like the handling of live explosives.
Right. That's the baseline we've set.
But what happens when the machine's cognitive architecture fundamentally disagrees with its human operator?
The introduction of true physical autonomy creates an inevitable high-stakes paradox.
Imagine a vision-language action model holding a highly volatile material. It has tokenized the physical space. It understands the ambient temperature, the degradation of the casing, and the precise physics of the danger.
It sees everything.
A human operator, perhaps lacking that microscopic physical awareness, gives the machine a direct, natural language command to move the material quickly to a new table.
Right. Hurry up and move that.
The machine calculates, based on its deep generative cognition of the geometry and physics, that executing the human's command will result in a catastrophic explosion.
A literal disaster.
Executing the prompt violates its core mandate of human safety.
The machine is caught between two foundational pillars. Understand and execute the natural language command versus interpret the physical environment to restore human safety.
Exactly. So who has the ultimate authority when the machine understands the physics of the danger far better than the human giving the prompt?
It's a terrifying dilemma.
Does the AI blindly follow the order, acting like a 2015 robot, and trigger the explosion? Or does it refuse the human's natural language command, seizing ultimate control in order to guarantee human safety?
It has to choose.
Once you give a machine a nervous system and a mandate to protect life, the clean, binary certainty of obedience is gone forever. We are officially operating in completely uncharted territory. Thank you so much for joining us on this deep dive.